Right. So, Aliyah, what is he saying in all of these units of measurement are the prefixes, which is milli, centi, and kilo. Meters, as you can see here in the previous slide, that meters is used to measure length. So these prefixes shows us how much of one unit that we have available. So when it comes to meters, right? So let me show you. So we have millimeters, right? We have centimeters, meters, and then we have kilometers, right? So can anybody tell me how much one, excuse me for a second. All right, sorry about that. Let me just put my phone on silent. And could somebody please remind me at the beginning of our classes to just put my phone on silent as well as put your phones on silent? Okay, so these are for the older kids, Kimoy and Justin. Tell me, fill in this for me. What is a millimeter?
Millimeter. They are smaller version of a centimeter.
By how much? One the conversion. Kimoy, you want to help Justin?
1,000. It's about 1,000.
So, what we could say, how we would convert.
1/1,000.
1/1,000 units. That's very good, guys. 1
1/.
This one. Equation. Yeah, 1/1,000. 1/1,000 what?
Millimeter.
Units.
Oh shit. My goodness.
That's cookie, Kimoy. Okay, excuse me for a minute, please. Okay, class, sorry about that interruption. Hopefully we don't have any more like that this evening where I'm concerned. I'm very sorry. This is not usually how classes run. Right. So this millimeter represents 1/1,000 units. Not because each meter is equal to 1 unit. Because unit for measurement, what you notice, oh Lord, what is the same at the end of the prefixes is meter. The suffixes is meter. The prefixes tells us how much to divide by or multiply by. So millimeters and centimeters are actually, and this is not 1,000 units, by the way, I was actually wrong. But millimeters and centimeters are smaller units than meters. So you divide by a certain amount to get meters. Kilometers is larger than meters. So you multiply by a certain amount to get a kilometer. Let's look back here. Oh, right. So this is correct. This is correct. So we have 1,000, 1/1,000, and the unit for measurement here would be meters, right? Right. So for centimeters, we will have, somebody help me out here, please. If we have 1/1,000 meters, right? Tell me how much we would have for centimeter. 1/1 how much? Great, 1/100 is the answer, Aliyah. Excellent. Right? So 1/100. All right. So we are dividing to get millimeters and centimeters, right? And we are multiplying to get kilometers. So could anybody tell me, what do we multiply by to get kilometers? How many meters make up a kilometer?
1,000.
1,000. Kimoy, what say you?
1,000.
Aliyah? You agree with that?
1,000.
Correct. Right? So 1,000 multiplied by 1 meter. Now, what I'm going to do, I'm going to leave this up here. And I'm going to what I'm actually going to do is create these for the others. And I want you guys to help me fill it in. So we know the unit here is liters, right? Now I'm going to give you, right. But tell me, how do I get milliliters?
And that will be 1/1,000.
Correct. But 1/1,000 what?
1/1,000 liters.
Correct?
Yes.
All right. What about centimeters?
1/100, I think.
Correct, but that is correct. So 1/1,000 what?
No, liters.
Correct. And our last one is kiloliters. What do we do here?
1,000 by 1 liter.
Correct. So what do you think we're going to do for the rest of them in mass? So this is volume, right? Let's look at mass. Hold on, I'm going to set it up so you all can call out your answers. I like how they call out all their answers, man. And they're speaking with confidence. I love that. I didn't notice something what I write there.
Yes.
I write the correct thing.
No.
What's it supposed to be?
Supposed to
MCG.
be MCG. MCG. No, it's supposed to be MCG, MG, CG, G, and KG.
Correct. With a smart class like all they'll keep me on my toes. Yes, I have to come prepared every single class. Else I look dummy, yes. All right. So we put in 1 gram here. Selma, talk to me. We have MCG, which we didn't have in these. Although it have micrometers and micrometers, but I didn't put the T because I wanted to see what you all would come up with for this one. So tell me, what we divided by here?
100,000.
That is correct. Right, and this we see this here. We're actually dividing by 1, 2, 3, a million. 4, 3. Sorry, I don't have on my glasses. 1, 2, 3, 4, 5, 6. Yes, so it's a million. Right? So we're actually dividing by a million. Right? So 1, 2, 3, 2. Let me make sure I type in the correct thing, you know.
1, 2, 3. Oh yeah.
Right. Right. So now we're moving on. Milligrams.
Let's see.
1/1000.
Correct. Very good, Aliyah. Centigrams.
1/100.
Correct. And kilograms.
1,000,000 multiplied by 1 gram.
No, 1,000 multiplied by 1 gram, but good effort. All right, so you guys understand this a bit better now?
Yes.
Yeah.
All right, so let me go back to the first slide. So we have volume means the amount of space an object or substance take up, right? So let me go to another slide. Let me create a new slide. And I want you to read through on your own just for a minute while I get some pictures to represent volume. So read through what volume is, and when I come back and asking all the questions. Huh? You all still seeing the notes on volume, correct?
Miss? Yeah.
Okay. All right, I'll come back. So, who ready to try and explain volume to me? And I'm looking at Justin and Kimoy because you guys will get in trouble with this section. And I'm hoping that after I did these, that you guys might be able to explain it to me instead. Because suppose I forget what I teach you, because all you just see how much mistakes I make here. I mean, yes, as a teacher, but I will make mistakes. So suppose I forget what I was supposed to teach. All you tell me, talk to me. Justin and Kimoy. Aliyah, if you have an idea, feel free to tell us. Even if you have the wrong concept, that is okay. You will still know that you have the wrong idea and you will be corrected. Nobody are making fun of you here, right?
Okay.
Okay, good. Talk to me, guys.
Basically, repeat what I was now saying, please.
I want you all, especially you and Justin, to explain to me or rather teach me after all I read the notes and volume, which is this section here, right? Teach me, like if I forget what this is about. That's why I tell all to read the notes while I was going, huh? Aliyah, you want to help them out?
Miss, wait, wait.
All right.
Miss, this part real confusing.
It's real confusing. All you agree with she, Justin and Kimoy?
Yeah.
Yes.
All right, well, let me see. So I have a picture here for you, right? So they say that volume means the amount of space an object or system or substance takes up, right? So let me deal with liquids for now. So I have one picture. Who knows what this is?
Coke.
Okay, and how much of let us be drinking Cokes when they come?
Me.
Me.
Aha. All right, so let me go back and let me copy and paste this definition here, right? Wait, the text go all the way off the pages. All right. So, read the definition. Volume means the amount of space an object or substance takes up. So a substance could be formed in a liquid, a solid, or a gas. And it have dimensions of length, right? So let me just let me just stay with this up to this sentence for now. What it is fills these bottles, the can, the tin, the glass bottle, and all the rest of them. What it is you have inside here? A liquid, a solid, or a gas?
A
A liquid.
All right. So you think that we could calculate the volume of a Coke?
Yes,
Yes.
Why?
because it have liquid inside of it, and it could measure the liquid with how much the diameter. The diameter,
The substance,
the amount.
the amount of it. Yeah.
All right. Now they say for solid shapes, and I feel this word here is what confused all you a little bit. So dimensions for solid shapes are going back and looking for a picture for you. Leaving this right here. And I want all you to take all the time and look at it. So coming back, when I tell all you read something, I'm coming back and asking all the questions. All you have to teach me, huh? Don't forget that. Are you ready for me?
Yeah.
All right, my dear. So we're dealing here with liquids, and we understand that the liquid Coke inside of this takes up the space inside the bottle, and we can measure it and find the volume, right? What about something like this? Anybody ever see anything like this before?
Yes.
Yes.
Yeah. We all know we try to solve these things and it is take forever to solve it, right?
Yeah.
You think we could calculate the volume of this?
Yeah.
Yeah.
Hold on,
No.
hold on. I'm going to get a sneezing fit just now.
Wait.
All right, Justin, you said no, we can't measure the volume of this. So I'm directing this to you. Why do you think we cannot measure the volume?
Because volume deals with liquid
Ah,
and is a solid.
oh, I see. All right, Aliyah and Kimoy, or let's say that yes, we can measure the volume of this. Tell me why.
Miss, because I think volume could measure solid too. No?
Okay, Kimoy?
This I think you could measure the solid too.
All right. Well, let me go back to the definition, right? It says volume means the amount of space an object or substance takes up. So Justin, in the scenario with the Coke, the liquid is a substance that takes up the space of the bottle. Now let me show you something here. Do you know that the bottle also takes up space on the table? And the bottle has its own volume. But because it's hollow inside, it's meant to hold the liquid. When we look at the cube, we can hold it in our hands, we can feel it, it takes up space. This is not a substance, it is an object. It is a solid object.
Oh.
Therefore, we can measure the volume. The difference lies in how we calculate the volume for the liquid when compared to dealing with the solid. So the explanation goes on to say that for solid shapes, so now when I say for solid shapes, they're talking about this cube here. So for solid shapes with dimensions of length, capture where you're coming from? Do you remember our slide where we did our conversions here? Right? This would be
Yes.
4 liters. We can also use, so because this is a cube, unlike this triangle here, this triangle is 2-dimensional. So let's say we had, let me triangle, my bad, square. You see, all not even correcting myself, and all I have to say calling it square triangle. What kind of students all is? Nobody is saying nothing, eh? Everybody stay quiet, laughing at Miss. All right, man. This would be 5 centimeters all the way around, right? No, I want the right side. Right? So this is 5 centimeters all the way around. This, however, this is 2-dimensional, which means you only see this side of it. This is 3-dimensional. So you have this angle here, right? And then you have this side, and because it's a cube, just like a square, each side would have one straight line. So if this is 5 centimeters here, it's 5 centimeters here, it's 5 centimeters here, 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 5 centimeters here. Now, how we would calculate the volume of this? We are multiplying the area of each side by each other, right? So in this instance, because we know, okay, so we have 10 minutes left, and I'm just gonna wrap up this explanation, and we're gonna do the same thing as last time. We're gonna log out, you have a 5-minute break, and you're gonna get back here in 5 minutes exact, right? So do whatever you wanna do, go on your phone, go on Facebook, message a friend, answer your friends, whatever, you have 5 minutes to do so after the explanation. So now it's 6:10, I'm going up to 6:15, and then I'm cutting off the meeting. And then you guys have 5 minutes, and I started it back at 6:20. Understood?
Yes.
Okay, good. So imagine that this square represents one side, right? So we would have to get the volume. And look, we have it here in our first slide here. Actually, is it in the first slide? Calculate volume. No, we're just converting right now. Okay, so let's not go into the volume aspect as yet. Let's not. Let's stick with what we have here. So we want to convert. Now, notice what they say. For liquids, we measure volume in liters. And for solids, right? For solid shapes with length, as is the case here, we measure volume in terms of meters cubed. And this cube means we are taking the area of each side and multiplying it by each other. So we know 5, how do we get the area of a square, people? How do we get the area of a square?
Side by side.
Side by side. So 5 by 5 will give you 25. So we know the area of one side is 25. So we want to find the area of 3. It's going to be 25 to the power of 3, or 25 by 25 by 25. What's the answer for that? You guys could use calculators, huh?
75.
75, 25 to the power of 3.
No.
That's not it. That's not.
So let me write it out there. You have area of one side is equal to side by side, which is equal to 5. Wait. Yeah. That's not.
$2.25.
Right. So something that I said wrong. I said it wrong. And that is, it's not side the area, because we have area of a square, it's side by side, right? That will give you
This is 225.
25, right? Just now, Kimoy, the volume of the square, you would have 3 sides to measure. So you're measuring this side, and this side. So will give you side by side by side. So if you have 5, It's going to be 5 multiplied by 5 multiplied by 5. And that will give us, what was your answer, Kimoy?
Yes.
25.
It's 15.
25.
125, guys.
No.
No. No. Oh, yeah. Oh,
225.
it's 225.
Are you worked it out on the calculator? And we're not dealing with the area, you know? We're dealing with the volume of the cube. And if the formula for volume of a cube, not square, volume of a cube is side cube. So side cube is 5, this is the dimensions we're working with. So it's 5 multiplied by 5 multiplied by 5, which is 125 centimeters. Let me pull up the calculator here so you can see that. As a matter of fact, go for a break and we will discuss this after a break. So it's 6:15, log out, and then thing.
It's true.